picking it up. Just did these examples. Okay, critical number. We know what that is. We know how to find them. Let's move on. And here we see the step-by-step process for how to find absolute maximums and minimums. So let's check it out. Finding the absolute max or min of f of x. Notice that we're always going to be considering this on an interval from a to b. Typically, we don't think about the entire domain of the function. We think about it as like a closed domain, starting at A and ending at B when it comes to absolute maximums and minimums. Usually that's the case because if we allowed the entire function, then too oftentimes the absolute max or min, there wouldn't be one, right? Because it would shoot off to infinity, maybe in one direction or both. Also, just for where this is going, there'll be a later section that takes this application a step further. And we'll always have a closed domain, or like the domain will be a closed interval, if you will, for those applications we're going to see later on as well. So we might as well get that practiced now. Okay, so it's this three-step process. The first step, notice, involves critical numbers. So we're going to find f of c for all critical numbers c in AB. So the first thing we'll have to do, like kind of what's assumed there, is that you find the critical numbers. So we'll have to find the critical numbers first. Once we have the critical numbers, then we're going to find their y values. We're going to plug those c's back into the function and see what y values those occur at. Okay, very good. Step number two, we're going to find f of a and f of b. And notice that A and B are the endpoints on the interval. So we're going to find the y value of the left endpoint, and we're going to find the y value of the right endpoint. So after we're done with 1 and 2, essentially what we're doing is we're creating a big list of y values. Where are all of the interesting y values? Where do they occur? Where do they occur for critical numbers? Because that's where an absolute max or min might occur. But also, what are the y values at the endpoints? Because if you remember from the beginning, endpoints could be an absolute max or min. So we have to consider those as well. Once we have all of the most interesting, all the possible candidates, all these y values, then step 3 is not really a step in that you're doing math. You're just kind of reflecting back on that list, and the largest of those y values is your absolute max. The smallest is the absolute min. So there's really not much to do. Once you have them all, just be sure you pick out the correct ones. Okay, so we're going to just take a look at this one polynomial example. Find the absolute max and min for f of x equals x to the 4th minus 2x squared plus 7. Okay, let me switch over. Example. Find absolute max and min. Okay, and we have f of x. Oh, looks like I forgot to indicate the interval we're going to be working with on the slide. So I'll do that now. We definitely need to know what interval we're looking at here. We're going to do this for the interval -2 to 3. All right. So how do we begin? We're going to go with the steps. Step number 1 said, hey, for all the criticals, find the y values. Well, we need to know the criticals first. To know the criticals, we need the derivative. So here, well, all right, 4x cubed minus 4x. And then we need to know where will this equal 0. There's like all these levels of steps. So first step is find the y values of the criticals, but that means you need to know the criticals. Well, what's the first step of finding the criticals? It's the derivative, right? Okay. then set it equal to 0. All right, so we have this 4x cubed minus 4x equals 0. How are we going to find these values of x? Factor of 4x, leaving x squared minus 1. And then we notice, oh, I can factor that even more. 4x, x minus 1 times x plus 1, 0, perfect. And we realize, oh, we have 3 factors. So 4x could equal 0, meaning x could equal 0. X could equal 1. X could equal -1. Okay, 3 criticals so far. Don't forget to check where your derivative is d and e. Here we've got a polynomial, so we're good. There's no cusps in a polynomial. So there are none. Don't skip this. Be sure to check. It's easy to kind of fall into this lull of just solving equal to 0, and that's it. But some of those, occasionally one's going to sneak by you here if you don't check it. All right. So we have these 3 criticals. We need to know their y values. So we go back to the function. We're going to plug them all into the original function right there. X to the 4th minus 2x squared plus 7. So let's find f of 0. Let me copy f of x over right here so we have it on the screen. Okay, well, f of 0, no problem. That's going to be 7. How about f of 1? Okay. 1 minus 2, -1 plus 7 is 6. And f of -1, we have even powers, right? A 4th and a square. So that would still be 1 minus 2 plus 7, still going to be 6. All right. Perfect. Step number 1, the longest step, we got it. The y values of all of the criticals. All right. Step number 2 is to find the y values at the endpoints. So our endpoints were at -2 and at 3. Okay. Well, still plugging in to the function x to the 4th minus 2x squared plus 7. Plugging -2 in, I'll let you guys confirm if I've got it. I got 15. And plugging in 3 to the 4th is pretty big. I got 70 right here. All right. Now that we have this list, we can just look down it and think, all right, well, which is the biggest one, y value, which is the smallest y value? Our absolute max is the biggest, 70. And remember, it's just the y value. Technically, if you list the full point, right, 370, not a big deal. Technically, though, it's just the y value. And the absolute min, the smallest. Notice we had a tie for the smallest at 6. That's no problem because all we got to say is y equals 6. And we got it. The highest function value on that domain and the lowest function value, the lowest y value on that domain. Let's jump over to Desmos really quick. Let's see, just kind of see what this looks like. Let's say y equals x to the 4th minus 2x squared plus 7. Okay, it's got this kind of W shape. I'm going to graph the endpoints at 2 and at 3. So there's 2. And we can see it hits there at 15. Yeah, just like we found. Then it drops down, right, does this. And then the green is way up at 70. Right, there's where that hits. And yeah, we can see, yep, that's definitely the maximum on this interval. And the minimum happened twice with this W shape, both occurring there at 6, 1, 6, and negative 1, 6 for sure. Okay. Hey, let's for a moment just sort of imagine something else here with the example. What if I change it just slightly? Let's say this. Let's keep the same function, but let me change the interval to now be from 0 to 3 instead of negative 2 to 3. How would that affect the problem? How would that affect the answers? Okay, so when it comes to finding the criticals, nothing would change. You would find the derivative, you would set it equal to 0, you would solve. So you would come and say, okay, we had 3 of these, right? At x equals 0, x equals 1, x equals negative 1. That would all work out the same. But take a closer look now. One of these criticals is not in the domain that we're interested in, negative 1. So we could just ignore that right away. Ignore, since it's not in the interval. If you come up with a critical number that's not in your interval, well, we're just not considering that. It's not going to lead to a possible absolute max or min because we're only worried about the interval from 0 to 3 here. Now, 0 itself, we're going to keep, you know, that's on the endpoint. That's fine. Obviously, 1 is between 0 and 3. So we're good with those. So what we do is say, okay, let's check f of 0, right? Our first critical. That would have given us 7. Let's check f of 1. Plug it in. That's going to give us 6. Then we need to check the endpoints. Well, we already checked the 0 endpoint. So we only need to check the 3. That's going to give 70. And then we can choose from these what is the absolute max and min. And we still get the same maximum at 70. We still get the same min at 6. But you kind of see how it played out quite a bit differently that when we ignore the negative 1. What would that look like graphically? Jump back over to Desmos. Say, okay, not at negative 2 any longer, but at 0 here. And so we're only focused on this little bit between the blue and the green. So yeah, you know, we still have that minimum at 6. We still have the max up at 70. But we just ignore this side completely, right? And we only focus on the domain that we care about. All right, you guys, that is all for 4.1.